All right, so I am going to pick off where we left off last time in section 1.4, which is titled Math Counts. Now, I'm actually going to split this one up into two separate videos. Um, I'm going to do a separate one entirely on sig figs and working with sig figs, just because that's such a big topic and I want you all to be able to find it and reference it easily. But anyway, this is section 1.4 essentially is just talking about making measurements. And of course, we did a lot of this in lab on Friday, but we're going to get into some more detail in it. Now, in science, in chemistry specifically, but in the sciences in general, we use a different system from what you have probably used up to this point in your life for a lot of other purposes. You're probably familiar with the what we sometimes call the imperial system or the American customary system, where, just for example, we measure length in feet, inches, miles, etc. Maybe we measure our weight. We measure weights in um, pounds and ounces. Weight, that's actually not the same thing as mass, which is usually what we're concerned about in science, but we're not going to really split hairs over that. Um, Maybe we've measured volumes, NO, say ounces. By the way, two different ounces, fluid ounces, or sorry, these are fluid ounces, but one fluid ounce of water has a weight of 1 ounce. But anyway, ounces, cups, quarts, gallons, etc. Like that. All right. So in science, you may have heard it said that in science we use the metric system. That's actually not totally correct. We use what is called the SI system, the International System of Units. Okay. Of course, that abbreviation makes perfect sense. SI system, it's actually French abbreviation, System International. But in any case, the way the SI system differs from the metric system is essentially, or kind of the big way that it does, is that the SI system really is more comprehensive than the metric system. It covers more measures and so forth than the metric system does. But and also a big thing in the SI system is that everything is traceable to an agreed standard. And actually, there's been some shakeup in those what those standards are in the last few years. Interesting topic in and of itself, but that's far too much of a diversion from what we're actually talking about here. In any case, though, in the SI system, though, when we want to talk about length, so first of all, in the SI system, we have this concept called, or let me, I'm backtracking a little bit for this. In the SI system, we have this concept called base units. And we pair those with prefixes. And I'll kind of flesh that out a little bit more and explain those by giving some examples. So in the SI system, our base unit for length is the meter. Now, how long is a meter? A meter is approximately 39 and a half inches. In other words, it's a little bit longer than 3 feet or about one little longer than 1 yard. Now, that's not always a convenient unit of measure or a convenient unit of length to use. So maybe if we're measuring distances, we want to look at 1,000 meters at a time, right? That gives us something called a kilometer or kilometer. This prefix kilo means 1,000. right? So a kilometer is 1,000 meters. Or maybe we think that that's too big. Maybe a kilometer or a meter is too long for what we're measuring. So we could talk about centimeters. Right? A centimeter, centi means 1/100th of a meter. Okay. Now, how big is a centimeter? Actually, this graph paper that I'm writing on is a 1/2 centimeter grid, right? Centimeter is about the width, kind of the rule I learned, and you can actually see this if I put it on the graph paper. Your pinky is about the width of a centimeter, or is about a centimeter wide. Okay, beyond there, though, we can have the millimeter. That's very, very common. That is 1/1000th of a meter, or 1/10th of a centimeter. Beyond there, too, we can get even smaller and smaller. We have the micrometer or the micron, which is 1/1,000,000th of a meter. So on and so forth from there. Just to go a little bit further with this, our SI unit for mass, our SI base unit for mass is called the gram. Right? And then, of course, on from there, 1 gram, something very common, a kilogram. Of course, kilo means 1,000 grams. This is approximately 2.2 pounds. So if you have a paper copy of the textbook, or really any heavy book, that is about 1 kilogram. Right. Also on the other end of that, we have milligrams. That's a really common unit, just for example, for doses of medication. Milli, of course, means 1/1000th. Also, too, when we look in the SI system, we look at volume, right? Our base unit for volume is the liter. A liter is about 1 quart, is a little bit larger than 1 quart, I should say. Actually, yeah, a lot of times when I'm teaching this in class, I'll ask if anyone can tell me about how big can show me with their hands about how big 1 liter is. And not all, sometimes I'll have someone who can do it, but if I ask how big's a 2 liter, everyone can kind of visualize that. And you take half of that, that gives you the size of a liter. But very, very often in chemistry and really in other fields, we use the milliliter, right? 1/1000th of a liter. Now, a milliliter is a cube, or it is the volume, and I can actually draw this to scale on this paper, or maybe I can. No, I can't. All right, I think I got that. 1 milliliter is a cube that is 1 centimeter on each side, which means that 1 milliliter is one cm cubed, or 1 cubic centimeter, or 1 cc, which is an abbreviation you will see quite often. cc's and milliliters are interchangeable. They are one and the same. All right, we've talked about prefixes. There are several of these that I want you to learn. They are listed on table 1.3 in your textbook. Real quick off the top of my head, though, I want you to learn kilo, which is 1,000. I want you to learn centi, which is 1/100th. Milli, which is 1/1000th. And then micro and nano, right? So we'll go on. So those are just the ones that I want you to learn. All right. Now, when we look at handling units, and this is going to introduce a concept closely related to this, and it's something that I've seen several of you mention actually in the discussions, which is good. But this leads us to a concept called dimensional analysis, which I don't spend a lot of time in this class formally teaching dimensional analysis, but it is a useful tool, and I'm going to kind of teach it in a hand-waving way. Essentially, if we want to go from one unit to another, we can write something called a conversion factor. All right, so let's say we want to convert from centimeters to meters. We know that 100 centimeters equals 1 meter. All right, we know that because a centimeter is 1/100th of a meter. Or centi means 1/100th. From that, we can write two different things that we call conversion factors. One of those is we can say 1 meter over 100 centimeters, which let me abbreviate that just to make it a little bit tidier. 100 centimeters, or we can say 100 centimeters over 1 meter. All right, so let's say that we have 273 centimeters, and we want to know how many meters that is. All right, so how many meters is 273 centimeters? Here's how I can use this kind of framework to calculate that. I can write 273 centimeters here. And then I want to multiply this by a conversion factor that's going to cancel out my unit I want to get rid of and give me the unit that I want. Right? So if I multiply this by 1 meter over 100 centimeters, that gives me centimeters on the top here, centimeters on the bottom here, something on the top and the bottom that can cancel. The only unit left here is meters on top, which is what I want. So basically, this is telling me that I take the 273 centimeters, divide it by 100, and I get 2.73 meters. Okay. I can do this same thing if, let's say that I want to calculate how many, let's say that I know that something is 190 pounds. I want to know how many kilograms. Right. So I said this earlier, this is not something that you will be responsible for knowing. It will be provided to you, but we know that 1 kilogram is equal to 2.2 pounds. So from that, I can write 1 kg over 2.2 pounds. LBS, of course, is our abbreviation for pounds. Where I can write 2.2 pounds over 1 kg. Now, if I want to solve this, I can say 190 pounds times, you look, I want to use the conversion factor basically that has pounds on the bottom. So I'm going to say times 1 kilogram over 2.2 pounds. And when I do that, I find that I get 86.4 kilograms. Actually, really, I should say 86 kilograms. Now, why look at the next video on sig figs or watch the next video on sig figs and I'll cover that. All right, but that's the first half of section 1.4. So now, like I said, I will cover the second half on sig figs in a separate video.